Okay, so next is question number 5. So what it says, in a parallelogram ABCD, E and F are the midpoint. So this is the midpoint they have said, means this and this equal. This is the midpoint they have said, this and this equal. And they have said ABCD is a parallelogram, means this opposite side will be same, this opposite side will be same and parallel also. Okay. So let me write down here. Okay. Now see one thing, this AB and CD are same, right? Means this is 6 centimeter, then this also will be 6 centimeter because it's a parallelogram, right? Now they have said this is midpoint. So if this is midpoint, this will be how much? 3. This also will be 3. Now this is also midpoint according to question E and F midpoint. So this and this also must be equal, then this will be how much? 3 and this also 3. So can I say this and this also equal, this and this also equal? Or this and this equal, this and this equal? I can say that also, okay? So these things you need to know, okay? Next, show that the line segment AF and EC. Show that the line segment AF and EC, this is your EC, okay? Trisect the diagonal BD. Trisect means cut into 3 equal parts. Bisect means what? Bisect means a point cuts a line into 2 equal parts. This and this will be same. Trisect means there will be 2 points. Okay, it will divide the line into 3 equal parts. Okay, so this line, you can see this line, it trisect this line at this point and this point, means this you have to show equal to equal. This is equal to this is equal to this. So AF and EC trisect diagonal BD, means this line and this line trisect, means cut this BD into 3 equal parts. You have to show, means this you have to show equal to this, okay, this 3 equal you have to show. Now the question is how you will show that. So see here, we know that we have the information what, this and this parallel, this and this parallel and equal also. This is the midpoint, this is the midpoint. Now the question is how you will show this equal. So see here, first I will show this and this to equal, 2 at a time. This and this to show equal. Now you can see information you have, this line, it's falling under this triangle, you can see. Okay, and to show this and this equal, I just have to show this is the midpoint. So remember midpoint theorem. In this triangle, can I use midpoint theorem and can show that this is midpoint? If I can show this is midpoint, my problem solved. This and this equal, I will understand. Now in this triangle, the question is how you will show this one midpoint. So see here how I will use the information. If I can show in this triangle, if I can show this line is parallel to this, and this is the midpoint, then remember the midpoint theorem. What midpoint theorem says? In a triangle, from one side, if you draw a line segment from a midpoint to another side, such that the line will be parallel to the second side, then this line always bisect this third side. Okay, bisect means it will cut from the midpoint. Okay, so if I have a triangle where I know there is a midpoint, and through that midpoint a line is parallel to the second side. This is your first side through which I am taking the midpoint. Okay, from this midpoint I will draw a line parallel to second side. If I have this one, then there is a theorem which proof I have already given. There is a theorem that this line always pass from the midpoint of the third side. So in this case also, in this triangle, you can see this is the midpoint, right? In this triangle, this is the midpoint. Now from this midpoint there is a line segment like this, and it passed from here. Now if I can show that this line is parallel to this, let me draw this one separately, this diagram. This is the triangle, right? And this is your F, midpoint. So from midpoint I am drawing a line. If I can show this is parallel to this, then I can say that this is midpoint from the midpoint theorem. So to show this and this equal, I have to show this point midpoint, right? This to show midpoint, I just have to show this is parallel to this. If I can show, my problem solved. I can show this is equal. And to show this and this equal, similarly you can use this triangle. Okay, similar. Now the question is how you will show this one parallel. Very simple. See here this line and this line carefully. To show this parallel, what I will do is, I already got this and this equal, right? And this is also parallel. So can I say from the parallelogram theorem, If the pair of opposite sides are parallel and equal, then the other pair of opposite sides also will be parallel. So it will form a parallelogram basically, right? So if this forms a parallelogram, I can say this is a parallel line. So this is parallel line means this will be the midpoint. Okay, so already I have the information. I don't need to draw any construction or anything here. I just use the given information here. So you just write down given information first. Given information is what? A, B, C, D. You'll start like this. A, B, C, D is a parallelogram. Okay, where E and F are midpoint. Okay, now in triangle, I'm going to take this triangle, right? DQC or DCQ you can write. F is midpoint of side DC. You can see F is midpoint of side DC. How I'm writing this one statement? I told you I have to show this one midpoint, right? To show midpoint, I will use the theorem. What is the theorem? Midpoint theorem. From one side of a triangle, if you select a midpoint and draw a line segment which is parallel to second side, then it will always pass from the midpoint of the third side. Okay, so I just have to show. Right now I have, this is already given midpoint, so you don't have to show anything for this. Just the thing is I have to show this one parallel because this is not given to you. If I can show parallel, then I can say this is the midpoint. Okay, so that's why first information I have written F is midpoint, okay, of DC. Now I will show this is parallel to this. Now how I will show that one? Very simple. We know that this and this equal. How we know that? Let me write down. Since you can write since AB is equal to CD, which implies half of AB will be equal to half of CD. Obviously, right? If AB and CD equal means 6, 6 suppose, then half of 6 will be how much? 3, half of CD also 3. Now why I am writing this? Because see, this is half of AB or not, this portion, because this is the midpoint, right? Half of AB and this is half of CD. So can I write half of AB, AE is equal to, can I write EC? Half of CD is what? Can I write EC? So this and this equal. From the diagram you already know. The thing is whether you can write or not. Okay, writing is again is a skill. Okay, so this you have understood from the diagram that it will be equal, right? Now how you will write that one? So very simple. CD and AB equal, so half of AB is this one. Can I write half of this one? AB is this, half of CD, can I write this one? So this and this equal. I got it. Next again N, you can write N AE parallel to EC. Yes or no? Because this AB and CD parallel means what? EC and this one also parallel. So if this is parallel and equal, then this will become parallelogram. Therefore, AECF is a parallelogram. Okay, now if this is parallelogram, can I write? Which implies PF parallel to QC. Done. So if this is parallel, can I say now this is the midpoint? Therefore, P is midpoint of DQ. Why? Midpoint theorem. Midpoint theorem. I hope you can see, right? Midpoint theorem. Okay, you just follow the step and write down. Midpoint theorem. So this is the midpoint. So if this is midpoint, can I write? Therefore, DE is equal to DP is equal to PQ. DP is equal to PQ. Now I just have to show this and this also equal. If I can show this and this equal, then can I say or not? They are all equal. Means AF trisect EC I can say. Okay. So to show this two equal, what I will do? I will not prove again. What I will write? Similarly in triangle, which triangle you will take now? I have to show this and this equal. So this line is falling under which triangle? Can you see this triangle? So in triangle BPA or ABP, in triangle ABP, BQ is equal to QP. I will write BQ is equal to PQ. How I got this one? Similar to above proof. Similar to above proof means whatever I prove here, similarly I can prove this. BQ is equal to QP. Okay. Therefore, this you mark it as 1, this you mark it as 2. Therefore, from 1 and 2, can I write now? DP is equal to PQ is equal to BQ. Right? This is equal to this is equal to this. So, from this conclusion, I can directly write down. Therefore, AF and EC. AF and EC trisect BD. Can I write? EC trisect BD. Done. Okay.